we're now going to get into operations with fractions. I mean, adding, subtracting in the current module, and then we'll get to multiplication and division in future modules. But before we tackle it, I want to make this point. The thinking, and that's why this image is on the screen, the thinking in a child's brain about fractions could be so confusing. I'm not saying we make it confusing or that it need not be confusing. It's just the nature of the mathematics is challenging here. So I share this with you as motivation that as you move forward in this module, consider how we can do things to create visual representations, that have something to think about, that we can help students in their ways of thinking, going back to mathematical meanings, like what does addition, subtraction, multiplication, division mean? How can we use tools appropriately? All the stuff you've been reading about to help with the issue I'm about to share here. So here's the issue. We start getting into fractions, and can you just imagine the thinking of a child? He says, okay, so when you add or subtract fractions, you have to get a common denominator for some reason. But you don't have to get a common denominator when you multiply or divide. I wonder why that is. I wonder why we have to have a common denominator. And in adding and subtracting, once we get a common denominator, we add or subtract the numerators, but we leave that common denominator alone. Well, that's interesting. I wonder why that is. Why does it work out that way, that we end up adding numerators, but we leave the denominator alone? And when we multiply, we actually multiply both the numerators and denominators. Maybe you remember this algorithm. You just multiply straight across with multiplication. I wonder why that is. How come we do that with multiplication, but with addition it doesn't work out that way? And then when we divide neither the numerators or denominators. And I'll go back through this below. With addition, once you have a common denominator, you add just the numerators, keep the denominator as it was. With multiplication, you multiply both numerators and denominators straight across. But with division, you don't divide. In fact, what you do with division is you keep the first fraction, you change the division to multiplication, you take the second fraction and flip it, and then you multiply. What? Do you see how this could be so confusing? All the rules. And then as you're going to find out as you go through these modules, what happens with kids is all these rules may or may not make great sense to them. And so in their brain, rather than having a well-connected network of understanding, they've got kind of a discombobulated network of random facts. And so as you're going to see in this module, what happens is kids later on will start crisscrossing the algorithms. When they're multiplying, they'll want to get common denominators. And when they're adding, they'll want to flip. And then you learn an algorithm where you cross multiply sometimes. And so sometimes they want to cross multiply. It's just like almost like a random guess of, I think I'm going to grab this algorithm and throw it at this problem and hope that I get it right. And we have to fix that. How do we get students, how do we develop their ways of thinking? So instead of this confused kid, we have kids who are mathematically powerfully thinking about the ideas and able to do, based on their thinking, they're able to do the right thing at the right time and get the right answer. That's what you're going to face in this next couple of modules.